Alright, today we're going to work on graphing rational functions. So I want to remind you of how to find a few things. So when we're finding horizontal and oblique asymptotes, we want to divide the highest power from both the top and the bottom. So in this case we'd be dividing the x and the 2x squared. Once you divide that, you reduce it, we get 1 over 2x. Now notice that this is in the a over bx form. There's still an x on the bottom, which means we can't divide the 2x into the 1. We don't know how many times it'll go. So y is going to be 0 for our horizontal asymptote. So we'll have a horizontal asymptote where y equals 0. Now we call it the asymptotes. They're the spots where it doesn't actually cross, which means that we might have a function that looks similar to this, and we're finding the horizontal one right here, which is we just found y is equal to 0. Now if we have this example here, we would take the 2x cubed and divide it by the x squared, and we would get an answer of 2x. Now 2x, that is in this bottom form right here, ax over b. So then we're going to use long division to figure out our oblique asymptote, y equals mx plus b. We've already got the mx part, we just need the plus b part. So we don't have to do full long division, we only have to do part of the long division. So reminder of long division, this bottom part goes on the outside, the top part goes on the inside. 2x cubed plus x squared plus x plus 2. Now we already did the first part, 2x cubed divided by x squared, and we got an answer of 2x. So I'm going to put that right up here on top. Now notice that all I need is the constant. So I'm going to take this 2x, multiply it to everything in front, and I get 2x cubed minus 4x squared. Now with long division, don't forget you do have to subtract both of those. So 2x cubed minus 2x cubed, that's 0. X squared minus negative 4x squared. So minus negative changes it to plus. So we've got 1x squared plus 4x squared, that makes 5x squared. Now I don't really have to worry a whole lot about the rest of that, because I'm going to take this 5x squared, I'm going to divide it by the x squared, and that gives me plus 5. So this is what I'm looking for, 2x plus 5. I don't have to finish out the long division. I know that my oblique asymptote is y equals 2x plus 5. Now this would look like a function, this would look like a line going like this, and then we might have one like this. So we could have a function that looks kind of like this. So again, these asymptotes, these are lines that as we get really far out there, it gets super close to that line. Okay, so this one would get super close to it here. So the oblique asymptote that we were looking for, this is a horizontal, this is an oblique. So with our oblique asymptote, we would probably have a vertical asymptote like this, and then an oblique asymptote like this, and then we could have our function that looked similar to this. So you'll always you won't have a horizontal and an oblique, you will have one or the other. It'll either be oblique or it will be horizontal. Alright, so now reminder on all of it, how to graph these. So first off, how to find a hole. A hole is where we have one factor on top and it cancels or has the exact same factor on bottom. If it looks something like this, x plus 3 divided by x plus 3, that is 1. So if this were the case, we would have an x coordinate of negative 3 for our hole. And then we'd have to plug it back in to find the y value. But we'll get to an example like that. In this case, there's not factors that are the same on top and bottom, so there's not a hole. Vertical asymptotes, that's the ones that go straight up and down, and those are your x values. Or in other words, we want the denominator to equal 0 for your vertical asymptote. So for the denominator to equal 0, x would have to equal 2, because 2 minus 2 is 0. So vertical asymptote where x equals 2. So I'm going to go ahead and put that on our graph. We have a line where x equals 2, so I'm going to draw it going straight up and down at 2. Okay, the next thing was horizontal or oblique asymptote. We just went over that. And that is where we take the highest power from each, the top and the bottom, and we divide them. So we take these two things here. X divided by x, that's 1. So since it equals 1, that is the horizontal asymptote y equals 1. So recall that we had three things. Either there was an x left on bottom, which meant y equals 0. We ended up with just a number, and then y equals that number. Or we end up with an x or an x on top of a fraction, and so then we have to finish it off by doing long division, and that's the only one that is an oblique asymptote rather than a horizontal asymptote. So in this case, x divided by x is 1, that's the middle one, y equals 1. So I'm going to go ahead and put that on the graph as well. Up at y equals 1, draw a line going straight across. The next part, we're looking for the x-intercept. So recall, for it to be an x-intercept, the function has to be equal to 0. So for this to be equal to 0, any fraction to be equal to 0, there has to be a 0 on top and a number on bottom, and then it'll equal 0. So really we can ignore the bottom and just work with the numerator, x plus 5 equals 0, which means that for this to equal 0, we would subtract the 5 over, x would have to be negative 5. So our x-intercept is negative 5. I'll go ahead and put that on the graph as well. And then the last part for the y-intercept, recall that we plug in zeros for the x's when you're looking for the y-intercept. So plugging in a 0 on the top we get 5, on the bottom we get negative 2, and so that's negative 2.5 on our y-axis right here. Alright, now you can see that we've got 4 sections to our graph, split up by our asymptotes. We've got dots in one section of the graph, so I can go ahead and draw my line curving through those dots, getting closer and closer to each of the asymptotes here in this section. Okay, now the other side of the graph, it's either in the bottom section or it's in the top section, one or the other. So to figure out which one it is, we'll start plugging in numbers, plugging in x's to our function to figure out what side of the asymptote it's on, whether it's on the top portion of this or the bottom portion of this. So I'm going to pick numbers that apply to this section of the graph. So if I pick, say, where x equals 3, that would be on either here or here, right? So I plug in a 3. If I plug in a 3 up here and down here, 3 plus 5, that's 8. And 3 minus 2, that's 1. So I get an answer of 8. Plugging in a 3, got an answer of 8. Now notice that it looks like it's on this side. It should be on this side. And just to make sure, I'll plug in another number. So let's say I choose the number 5, right? So if I plug in a 5, 5 plus 5 is 10, and 5 minus 2 is 3. So that would be approximately 3.3. I plugged in a 5, and I got an answer of 123.3, approximately right there. So you can see that it is on this half of our graph. So we're going to draw our curved line going through those dots, kind of curving like this. So there's a graph of our function. If we wanted to get more accurate, we could plug in a whole bunch more numbers over here to get a bunch of dots to connect. But for this case, I'm mostly just wanting you to know which part of the graph it is in, and we figured out it's in the top, so we drew our line similar to this one down here. Okay, here's another function. Let's go back through it. We look for a whole. A whole is looking for factors that are the same on the top and the bottom that would equal 1. In this case, 3x minus 1, x plus 1. There's not, so we will write none for the whole. To find the vertical asymptote, that's the numbers that x cannot be equal to, or in other words, the domain part that is not included, which means that you're going to set the bottom equal to 0. For x plus 1 equals 0, we would minus the 1, and we'd get that x equals negative 1. Horizontal or oblique asymptotes. We divide the highest power from the top and from the bottom, so 3x divided by x gives us an answer of 3. And since that is a whole number, that's our horizontal asymptote where y equals 3. Remember that 1 over x means that y is 0. A number means that y is that number. And if we're left with an x, then we have to do long division to find the oblique asymptote. Since we got 3, then that means that y equals 3 for our horizontal asymptote. All right, finding the x-intercept. That is where the top part of a fraction equals 0. So we would set the top part of the fraction equal to 0. 3x minus 1 equals 0. We would add the 1 over, so 3x would equal 1, and divide by 3, so x-intercept of 1/3. The y-intercept, that's where you plug 0 in for your function. So if we plug a 0 here, and we plug a 0 here, on the top 3 times 0, that's 0, minus 1, so we get negative 1. On the bottom, 0 plus 1 is 1, so we have a y-intercept of negative 1. Now I'm going to go ahead and put the asymptotes on the graph where x equals negative 1 and where y equals 3. Now as you can see, we've got 4 sections of the graph. We've got dots down in this lower right section, so we would draw a line curving through those points, staying within our asymptotes, which means now we're looking at the left side. It's either up here at the top or down here at the bottom. So again, we're going to pick values that apply to that section of the graph and find out whether it's up here or down here. So as I choose x and y values, I want to choose x values that are on the left side. So I would choose maybe a negative 2. So if I plug in negative 2 for the top and the bottom, all the x's, 3 times negative 2, that's negative 6, minus 1, that's negative 7. And negative 2 plus 1, that's negative 1. So negative 7 over negative 1 gives positive 7 for my answer. So negative 2, positive 7. Alright, so that means it's in this top left portion of the graph. But just to make sure, I'm going to plug in another number. Let's say we choose negative 5. So if I plug negative 5 into the top and the bottom, 3 times negative 5 is negative 15, minus 1, that's negative 16. On the bottom, negative 5 plus 1, that's negative 4. So negative 16 divided by negative 4, that is 4. So at negative 5, we're up 4, and you can see that it is a line curving through these points, staying in the top left portion of your graph.